Okay, hello. My name is Jörg Grauvogl. I'm working for the network engineering team, data center network engineering team within T-Systems. I'm based in Germany, and I want to share some experience we gathered when starting our IPv6 project, especially for our platform we call Dynamic Services. So Dynamic Services is a platform within T-Systems which can be understood as a platform as a service offering. So the T-Systems operates the whole stack from the hardware, the network, the storage, the OSs up to the applications in terms of SAP installations, middleware, databases, and also third-party stuff. So here's the agenda. So to have a common starting point, I want to give you an overview how typical, from a server perspective, the data center would look like. Then, as you already can see on the agenda, we took the approach of a two-phase approach. The first step, which started already mid of last year, to go dual stack for the customer interfaces. So to enable the customer to access their services, they have outsourced to T-Systems via dual stack. And phase two, to go IPv6 in the backend networks in terms of storage and administrative traffic. So here we are. So slightly an overview with the server-centric in the middle here, what server group T-Systems data center will see. So we have at first the customer-facing interfaces. So he's got at least 3 interfaces. So customer-facing interface, which might be the access point, the corporate VPN of the customer, even served by another T-Systems entity, or also third party AT&T, PT, hitting our data center, going through a firewall with optional load balancing services which can be ordered for application redundancy or performance issue topics. And the second path for customer access might be the internet access with a DMZ and the servers being connected to the DMZ. So in terms of a traffic load, I would expect that we are serving mostly 90% of our customer access is coming via corporate network, meaning private IP addressing hitting the services within the data center. 10% about are internet-based services. And then in the backend network, we have a storage or backup infrastructure. Especially in the dynamic services platform, we've got some specialities in terms of running and provisioning Linux, even if it's doesn't matter if it's a VM or bare metal installation. So the Linux image is somehow streamed from the network. So it's a read-only image via PCI procedures. So this is, let's say, a stateless Linux provisioning. On the back end, we have admin firewalls distributed over our data centers, where first the TSI admins will access the services, operate the network, operate the operating system, and also the applications. And there, behind these clusters, also we have the control nodes and system management systems for all of the stuff we have within the customer environment. So, as already shown in the agenda, so the first phase, which we expected to finish or hopefully finish at the end of Q2, beginning of Q3 this year, is to enable the whole front end, including internet access in terms of IPv6 peering, the 3 POPs we have, including also our data center backbone to transport traffic to all of our distributed data centers within Germany and also international locations. Enable customer firewalls in terms of DMZ firewalls or internal firewalls, and also load balancer services and bring dual stack directly towards the applications which are operated within the data center. So, which challenges did we face at the early starting of our IPv6 project and even in phase 1? As already mentioned here, also the management aspect. So, it's really here a button-up approach that you really need as a technician to convince the management that IPv6 is a technology to go for, and IPv6 is necessary to ensure your future business. So then the organization, even in large enterprises like the T-Systems is one, you need to identify all the involved departments, create a project organization, allocate the resources, and also get the commitment for the resources, that they're not grabbed by other projects running within the company, and to create the project timeline. The human aspect we have, of course, you need the necessary training, starting from the engineering over the operations and also the project consultants, which later on consult our customers when doing the transitions from their data center installation into our data center. Also IPv6 is a new aspect then at this point. The provisioning systems, you need to identify all the systems which provide and document IP addresses, if they are at least IPv6 capable, in terms of database fields length, for example. The OSs, as I already mentioned regarding the stateless Linux deployment, we use we have a high grade of automation there, and also a lot of scripting which need to be adapted to also cover the IPv6 part on the customer interface. And also, at least the customer at this stage, the customer-facing application like web services, SAP services, which are accessed from the customers towards the data center. In terms of hardware-software roadmap from your vendors, we came over certain topics. For example, we need to start an evaluation of a new firewall hardware because existing hardware was not capable of handling IPv6 and hardware. And also, this is even a more critical aspect if you're talking about virtualized systems, virtualized firewalls, which are in a shared environment, where one customer which requests IPv6 might potentially impact the IPv4 traffic of other customers running on the same physical firewall. Load balancers, so this would be one example to really check the features which you're currently using in your hardware, that all of them support fully IPv6 functionality, especially in terms of the load balancers. We came over the topic that the load balancers support fully IPv6 with all of the features, but not as soon as you enable the virtualization. So we need to wait, and I think till now it's available, wait for the new software, do software release testing to introduce the new software on top of your existing hardware base. So now, coming to the second phase, which already started but has a little bit longer timeline. IPv6 only in the back end. So no dual stack, no IPv4 addressing, IPv6 only is our goal there, for storage backup connections and all the system management. The major background for this is, as I already mentioned, that 90% of our customers are corporate VPN customers hitting our data center with private IP address space. We see our real chance to distinguish and keep the routing table on the servers unique towards the customer connections. So we do not need any negotiation with the customer which IP addresses we use in our backend networks to administer and to provision the systems. So we're independent from the customer IP space, even if it's coming in via IPv4 or IPv6. So this is the basic idea there. So this is slightly started this process. So we already identified some highlights which we will come into. We do not have the complete answers for them, but just to highlight them, you even need to identify more of the systems which are running in the backend for administration purposes of your systems, and already also address protocols which are normally not used for the customer service themselves. For example, take a router which is IPv6 capable, does not necessarily mean that he is capable of doing SNMP and NTP via IPv6 on the management plane. So it's slightly different because what the devices can do on the data plane from what they cannot do on the management plane. The OSs, I think we will really get a hard time there because there are currently no standardized processes how to PXE or UEFI boot systems via IPv6. So the applications we need to take into consideration in terms of IPv6 will even grow For example, if you have a web server, which will be tackled in the first phase, to have customers accessing the web servers via IPv6 is one story, but what will happen if in the backend there's an Oracle database, also you need to check your databases and also database protocols. Storage, for backup or these live streamed Linux, you need to check all your storage appliances here, and also the protocols they use, even if it's NFS, iSCSI, or CIFS. Regarding the admin firewall, we have seen in the picture. So even there, you need to get your backend infrastructure in terms of admin traffic being IPv6, performing tests, and also one of the major aspects, because within T-Systems, our internal IT has not rolled out IPv6 yet. We need to have some transition phase, how we ensure that TSI admins, which have only an IPv6 office network, can access and can manage services which have IPv6 in the backend. So this will be achieved hopefully via some dual stack management zones where the admins access via IPv4 and can then from there on administer the systems via IPv6. So a lot of work to do in phase 2, but we really see the chance for this phase 2 approach to help us in performing the following things: that we save us or the services we provide to the customer, which they outsource to us, that we avoid address overlapping, that we do not need any IP address negotiation with the customer, or avoids also having painful NAT concepts for administering the systems. So thus, it enables you to highly standardize or even more standardize your network and IP infrastructure, simplify the management concept, overall reduces the costs, and also you will get some acceleration in the deployment of the customer projects. So that's so far from my side. Any specific questions at this point?